All right, we get to synthesis. This is like the whole goal of learning organic chemistry too. Synthesis, we just learn about a bunch of reaction and how we're gonna use those reactions in different order. Use protecting group, use some tips, some tricks, how to get to the product the most efficiently and the fastest way. Okay. All right. So synthesis. So we're gonna show you like a kind of review so far. So I'm sure you have seen this reaction right here. This is hydrogenation from alkyne back to alkene, back to alkane, or you can go forward, do elimination. All right. So you have seen from a secondary alcohol, you can oxidize it, you can reduce it to ketone. Primary alcohol, you can do oxidize it to aldehyde, reduce it back to alcohol, primary alcohol. All right. And these are all functional group transformation you have seen in OChem 1. All this right here. I'm sure some of them you probably have forgot it already. All right. But this is what we have. And plus, this is a new one excluding the benzene, the aromatic compound. No, that's another one. All right. So there are a bunch of this reaction. What are you going to do? Memorize them all? No. I told you never memorize this. Only thing I asked you to memorize pKa, right? All the pKa values. 1715 in IR. 60 ppm, that's in carbon NMR, and 3.7 in proton NMR. That's all you need to. The rest you do not memorize it. To be able to use all this, anything you see right here, there are two things that I want you to do. Number one, probably the hardest thing. You have to be familiar with it by using them often enough. There's no way around it. You have to go through synthesis problem after problem until you get a hang of it. Let's say, hey, an alcohol, how do you convert to aldehyde ketone? Oh, you can oxidize it, right? And what reagent, a few reagents should come up to your head, but you have to be familiar with it. Use them often enough. No way around it. I'll say one more time. You have to do synthesis problem. Do as much as you could. In the practice, the study guide I gave you have some, right? In the extra practice, have some more. Please go practice on those until you get it, right? Until you're familiar with all this. And you first, at the beginning, it's going to be slow. It will be really slow. But after you do that for a while, you get faster and faster. And that's what I want you to get to. Okay. And after that, this should be like a week or two. I want you to summarize all this reaction in your own way. Okay, in your own way. I'm going to give you my version, but there's no point use my version. You have to do on your own. Write this reaction without looking back to all this reaction like from your textbook. You have to be able to write it to make sure it's stick in your head. All right, and categorize it into whatever category you want to do. Here's my version. Okay, I like to group or categorize all this reaction in the way that, okay, this is how I'm going to use it, the purpose of it. For example, bond cleavage, right? Cutting bond. How many ways you can cut bond? Well, there are a few ways. This have to come up, all right? Let's take a look. So this reaction type, the bond cleavage type reaction, the features, loss of carbon chain. If you look at the product and reactant, something losing. Yeah, something got cut and lost it. Loss of carbon sigma bond. That's a feature of it, all right? So these are so one thing you should do when you do synthesis problem: count number of carbons. Always count, so you know what lose, what gain. Okay. All right. So here's our example: bond cleavage. So ozonolysis, cutting double bond. All right. So you should get aldehyde or get ketone, depends. You can do ozonolysis on an alkyne. You get carboxylic acid here. Carboxylic acid here. Okay. Yeah. The oxidized alkyne. The alkyne got oxidized twice. The first time you get aldehyde get oxidized further, carboxylic, yeah, you know those stuff. All right. Bayer vinegar oxidation. So remove carbon-carbon bond and insert oxygen in the middle. Okay, that's Bayer vinegar. I'll give you some example how to use this reaction or how to spot, like when to use this reaction later. All right. What else we get? All right. So the first one, that's bond cleavage. These three reactions help you cutting bond. The following reaction, there might be quite a bit more. Carbon-carbon chain extension. The feature of this type of reaction, they do the same thing. Extend a carbon chain. It means that you have to count number of carbons, and please do not forget to count number of carbons. Just like IR, NMR, if you have the molecular formula, what do? You do DOU first. Just you have to do that as a routine. Count number of carbons, right? All right, number one. So this in OChem 1, the very first reaction allow you to put carbon on carbon is alkylation of alkyne. Right, use sodium amide pronate right here. This terminal alkyne, and then nucleophilic attack or SN2 on an alkyl halide X lead. You get alkyl group on an alkyne. Cannot do with tertiary. That's SN2. So you can do reaction of Grignard reagent on epoxide. So an alkyl group attack the less sterically hindered site, you get the product. All right. You can do Grignard reagent with a carbonyl carbon aldehyde ketone. Now you get add an alkyl group onto aldehyde ketone. You can do cyanohydrin formation. This is cyanide, add one carbon, and you can do things on it later. This is the next chapter. Okay. All right. So this 4 reaction allows you to put carbon on carbon chain. Now, when do we do this reaction? Well, you can spot a few. All right. For this one, so if you use epoxide, you're gonna the result, the product, you have 2 groups, 2 carbons away, 1 to 2, 1 and 2, 2 carbons away because 1, 2 right here. Okay. If you use Grignard reagent, react with aldehyde ketone, the 2 groups are on the same carbon, like right there, on the same carbon. All right. All right, so we have 4 reactions so far. Actually, one more. We just learned this is a new one, Bidic reaction. All right, Bidic reaction is a reverse of ozonolysis. I said osmosis. No, ozonolysis. Right. So allow you to put carbon on aldehyde ketone, and you get alkene. Stay on alkene. Okay. One thing you have to consider: stabilized elite give you E, favor the E, and unstabilized elite favor Z. Okay. And lastly, please do not forget Friedel-Crafts alkylation or acylation. Right? We usually prefer acylation because there's no rearrangement. Right? And you can do Clemmensen reduction later. All right? But this one is reserved for just the benzene or aromatic compound. Okay. All right. You should be able to write all this reagent, the product without looking back to your textbook. You should be able to. If you have to look back to your textbook, every time it's gonna be slow. At the beginning, it's fine, but like after you master it, you practice for a while. Please do not do that. It takes too long. Okay. All right. The following reaction used to can be used for converting from functional group to a higher oxidation state functional group. Okay. So situation when you need to introduce new substituent or functional group transformation, you're gonna use oxidation reaction doing that. So aldehyde ketone. Can do aldehyde ketone epoxide can do wide range of reaction. Well, oxidation reaction usually used to make aldehyde ketone, and we can do a lot of reaction on aldehyde ketone. Okay. The very first one that you have learned, so PCC from primary to primary alcohol to aldehyde, and then you oxidize it. So we have 2 options of oxidizing agent: strong, right? You can convert that to carboxylic acid, or the PCC, which is the weaker one. Okay, or you can also use permanganate as well. All right. One thing you should know, so please don't forget tertiary alcohol cannot be oxidized. All right, the following also oxidation reaction on alkene. Okay, so we have Markovnikov hydration, anti-Markovnikov hydration, MCPPA, you get epoxide, and we can do things on epoxide. Alkyne can be oxidized as well. You get either ketone with Markovnikov hydration or anti-Markovnikov, you get aldehyde. Put OH right here. And you probably remember you get enol, right? The tautomerized to aldehyde or ketone. Okay. And last one, so oxidation at the benzylic position, right? So we add a sodium dichromate in sulfuric acid. But this one, so I missed one thing. Please add heat right here. You need to add heat. Benzene system usually more stable. If you want reaction to happen, you have to force it a little. In this case, you just add a little heat right here. All right. In aldehyde ketone, just room temperature works. But this guy need to add heat. Add heat right here. I forget heat. Okay. All right. So oxidation. Well, we're gonna have reduction. Now, list of all reducing agent. If you can do that, it means you have that in your head. Okay. So the situation that you're gonna do reduction or functional group transformation. So the very first reduction is catalytic hydrogenation. Right? You can do hydrogenate alkene, you get alkane. You can do the same with alkyne. You get alkane, but you can also stop at alkene. Depends on what you want to use. Lindlar catalyst got cis. So sodium in liquid ammonia, you got trans. Okay. You can also reduce aldehyde or ketone using hydrogenation, sodium borohydride, lithium aluminum hydride. Do not put lithium aluminum hydride with an acid. They react one another. Okay. You can also reduce epoxide, so hydride attack on the least substitute carbon. You get the product as well. All right. And all these are new. You just have learned. So the reduction of ketone and aldehyde, add cyclic thioacetal, and remove the whole thing with using Rennie nickel. I forgot hydrogen gas. Can you put hydrogen gas right here? All right, you need hydrogen gas in there. So hydrogen gas, use Rennie nickel as a catalyst. You get this. All right. With Kirchner reduction, also aldehyde and ketone, use hydrazine. You get hydrazone, and then remove the whole thing. So under basic condition and elevated temperature, the to nitrogen leave as a nitrogen gas. Yep, you get alkane. Okay, and Clemmensen reduction, which is follow the was it Friedel-Crafts acylation? Do Clemmensen reduction right here. You get you get reduction reaction. And the following are protecting group. So what we got, so this chapter we have learned the protection of aldehyde ketone using acetal formation, right? Cyclic acetal. You can be protected with using acidic condition. Okay. Now go back to the last semester. So you probably have seen the protection of alcohol used trimethylsilyl chloride, TMSCl, and with pyridine or triethylamine as a base. You need a base as well. You have to look at the mechanism. Okay, put TMS right there, just like acetal formation, acetal, right? Cyclic acetal. Both of them are stable under basic condition, but not acidic condition. You can remove it if you're adding an acid catalyzed hydration, or use TBAP, tetrabutyl ammonium fluoride. Okay. Yes, silicon and fluoride form a really strong bond. Put TBAP into this functional group, it clips the oxygen and sulfur bond right away. Okay. All right, benzene. So you can you can protect it and deprotect it. You have talked about this already. All right. All right, one more time. So all these protecting group, they are stable under basic condition, but not acid. If you want to do things on protecting groups, so be careful. If you add any reagent that come with an acid, it will cleave this protecting group. So be careful. Okay. To prevent that, one of the best protecting group that we have in this course, right, is cyclic thioacetal, stable in both acidic and basic condition. Right. You can reduce it by using add hydrogen gas and Rennie nickel. Right. You can remove that this is reduction. Now you can remove the cyclic thioacetal by adding mercury to ion, this guy right here, and just remove it. You get ketone back. Okay. The textbook doesn't give you this reaction, but I give you. You are allowed to use it. Okay, you are allowed to use it on a quiz or an exam. It's just more useful, synthetic wise. Not always. So it's anyway. That's all you need to know. There's things behind practically, but you don't need to know that. All right. So that's a for protecting group. So pick and choose whatever you feel like want to do. Okay. All right. There are 4 examples of synthesis problem. I'll have you do as much as you could, as much as you can. All right. And check with me on the next video. Okay.